Hi everyone. Now we will start another interesting topic on a characterization of a material. So that is a mass spectrometry. So here after the infrared spectroscopy or a NMR, this technique is very or highly useful for characterization of a material. Using this technique, we can determine quantity of substance or qualitative amount of substance present in a given unknown sample. So here the term mass, so and spectrometry. So spectrometry is some tool by which we can determine the mass of any unknown compound given to you for the analysis. So first time the mass spectrum was recorded by J.J. Thomson from Cambridge University, England, and the first mass spectrograph was recorded by Francis W. Aston. Okay, for this development he got the Nobel Prize in 1922. So this is about history of a mass spectrometry. So here we will see what is a mass spectrometry, and here how the mass spectrometry can be compared with the weighing of a bulk material. Generally in daily life we weigh our body weight, okay, and generally body weight is depend upon the mass as well as the gravity, okay. So that include the weight of a bulk material, and we have physical balance as well as a digital balance to know the body weight. Then when the traditionally we measure the previously we measure the weight of any substance by physical balance, and still this weighing of material by physical balance is still existed. And here if we want to know the lower amount of weight of lower amount of any chemical substance or any material, we generally use a digital analytical balance. So with the help of digital analytical balance, we can know the weight of substance up to 1 microgram. And then the question arises, how we can determine the mass of molecules and atoms. Okay, so here mass, here the gravity is not involved, okay, because the W equal to m into g for determining the weight of the substance. But here we will how to determine the mass of any substance, or so we can determine mass of any molecule or a mass of a atom. Means we will use this mass spectrometry for determination of a different element that are present in a periodic table, okay, as well as the mass of molecules, any molecules that may be a biological origin or chemical origin, or that may be pollutant. So this mass spectrometry we can determine. It is a smallest scale to determine the weight of substance 1 attomole. Means we can determine the mass of any molecule or atom that present in a unknown sample in a 10 to the power minus 18 gram. So that is near to 1 molecule or 1 element present in a sample. So what is a mass spectrometry? It is a analytical technique, or it is a separation technique by which we will determine the composition of sample. And sample may be environmental sample like water or food sample, and it may be also biological origin. So the biological origin may be like blood, urine, serum sample, in which what are the chemical substance or biomolecules present in that sample, okay, and we can determine the chemical composition or we can determine the quantitative presence of a particular element present in the sample. The mass spectrometry has as described as a smallest scale in the world, because mass spectrometry is size, but because of the weight of a molecules present in the sample. So here we will see, okay, so we have understand now what is a mass spectrometry. So mass spectrometry is the separation technique by which we can determine mass of any molecule or element present in an unknown sample, that may be biological origin, environmental, or a pharmaceutical. Okay, now we will see what is the principle of mass spectrometer, how this instrument work, okay, for determination of a mass of molecule or mass of a element from the sample. So generally this mass spectrometer having three components. First one is an ionizer, mass analyzer, and a detector. So in ionizer, the term ionizer means that ionize the molecule or element, and mass analyzer part is filter, okay, filter the ionized molecules for the reaching to the detector. So the in conclusion, the principle of mass spectrometer involves the ionization of molecules or atoms or element, okay, followed by the separation. Okay, so mass analyzer will do the separation of ions by mass by charge ratio, and the particular the ionized molecule or particular element will reach to the detector for the identification of a unknown element or a molecules that may be present in a sample. So this is the principle of a mass spectrometry. So we can again now we will elaborate the determination, okay, or scheme for the determination of molecules in a mass spectrometry. So generally I told the ionizer, okay, so ionizer that we have EI, electron ionization, CI, chemical ionization, fast atom bombardment, ESI, electrospray ionization, then we have the MALDI, matrix assisted laser desorption ionization. So these ionization, okay, different types of ionization, okay, are technique that present in the ionizer part, okay, or that is the first component of a mass spectrometry. And for the different types of mass spectrometry, we have a different types of ionization source, okay, ionization source. So generally the ionization source ionize the molecule. So that suppose the molecular mass of any substance is, suppose if you are denoted as M, then when it will ionize, so it will be changes to M plus or M plus H, okay. So when the molecule is get protonated, it will become M plus H ion, okay. Then we have a mass analyzer, that is also called separation unit or filtration unit or a mass sorting out unit, and that is done by the help of mass by charge ratio. And we have different types of mass analyzer: sector, quadrupole, ion trap, and top. So Q means quadrupole, Q and T means quadrupole ion trap, and top means time of flight, okay. So this only the particular ions, okay, which get sorted in a mass analyzer passes to the detector, and other ions, molecular ions, will get off to the reaching to the detector. Then we will get a mass spectrum. And before so in the ionization source, there are a different ways by which we can introduce our sample. Either the sample may be in the solid form. When we will introduce our sample in the solid form, then that time we will use Maldi mass. Okay, and when we will introduce our sample in the form of a gas, then we will either use EI, CI or FAB. Okay, and when it is in the form of a liquid, so it may be ESI, electro spray ionization. Okay, and when this mass is connected to the HPLC, then it is called LCMS. When it connected with the GC with MS, then that is called GCMS. So the GC or LC will introduce the sample into the mass spectrometry. So that is about the summary of mass spectrometry. Now we will see the different ionization method. So we have a electron impact, that is also called electron ionization, and this is a very hard method. We will see why it is called hard method. And we can determine, using EI, we can determine the molecular mass from 100 to 2000 Dalton. And fast atom bombardment, that is also called FAB, semi-hard. And we can analyze peptides or sugars which having the molecular mass up to 6000 Dalton. And electro spray ionization is called soft ionization, and we can analyze the molecules which having a molecular weight up to 200,000 Dalton, and generally peptides and proteins containing this higher molecular mass. And matrix assisted laser desorption ionization is again soft ionization example, and we can determine the molecular mass up to 500,000 Dalton. So these are the summary for the ionization of molecules up to the different molecular mass. So first we will see the electron ionization. How the electron ionization works for the ionization of molecule in a mass spectrometry. So this is a block diagram. So this is a filament. So that filament is made up of a tungsten. Okay, tungsten. And when this filament is thermally heated, it will release electron from the filament, and this filament will ionize the molecule, and the M, molecular mass M, will get ionized. After the ionization, it passes through the mass analyzer, then it goes to the detector for the analysis. So this is a principle behind the working of a electron ionization. Then here how we can understand, okay, means this is the scheme or the ionization of molecule using EI. So from EI, the electron being collide with your molecule, and it will so this is the molecular formula. So you have and the molecules should be in the gaseous form. Molecule or element should be in the gaseous form. Then it will get a M plus, then again the ionized molecule should be again in the gaseous phase. So this is a scheme for the ionization of molecule in a EI. Then we can take the example of a methane. So when the methane is heated with a electron beam, then the molecule will get it take out one electron, and there is a removal of one electron from a methane, and it will form the radical cation. And this radical cation, because it is not stable in a mass spectrometry, so it will be form a carbocation, and this carbocation will be detected in a mass spectrometry, and there are different the fragmentation pattern, okay, for a methane after the heating with a electron beam. So generally this removal of hydrogen from the molecule is due to the bond breaking, and the formation of a radical cation is a removal of a electron beam. So you will see how the core electron released from the molecule, or how the electron is released from a breaking of a bonding electron. Okay, so here we will see. So this is again a scheme or a mechanism. Okay, how we can simply understand the principle or mechanism for a formation of a carbocation or a radical. Okay, so generally, suppose we will take the example of a propane, and when we will put this propane in a mass spectrometry, okay, and generally the propane molecule consists of CH bond. Okay, we have a 3 CH bond in this molecule, and consider one CH, okay, molecule from the propane, and it has bonding electron and a core electron. Generally, carbon having a 6 core electron and a 5 means from 5 is a core electron, and 1 core electron is used for the bonding with a hydrogen. When that electron beam, okay, electron beam hit the molecule or hit the core electron, so one core electron will be take off, okay, take off from the core shell, okay, and it will form the radical cation, okay, radical cation, or that is also called molecular ion. So molecular ion is also parent ion. Okay, so suppose what is the molecular mass of this molecule? 44. So we will get the peak at 44. Okay, we will get the peak at 44. So that is a molecular ion peak. Okay, so this is the formation of a radical cation. Okay, now in mass spectrometry we have a high magnetic field. When that radical cation pass through the high magnetic field followed by the detector, and when we will put that ionized molecule or ionized ion in a mass spectrometer, it follow curvature path. Okay, curvature path, and okay, then so this is a curvature path followed by the propane radical, okay, and that having radius r, okay, radius r, and now we know if that is the 12th class physics. So we know that when we will put any ion into the magnetic field, okay, and it follows the curvature path, okay, so it will have a centrifugal force. So the applied magnetic field is equal to centrifugal force, and generally the magnetic field QVB, Q is charge, V is applied voltage, and B is a magnetic field. Again, mass, voltage, velocity of ion divided by radius. Okay, so here what conclusion we will have with this formula? Finally, R equal to mass into applied velocity or applied voltage divided by charge into applied magnetic field. Means R is directly proportional to R is directly proportional to the mass. So more the mass of molecules, so more the path taken by a molecule to reach the detector. Okay, so if the mass is changed, R will change, and that based on that one it decides the molecular mass in a mass spectrometry. And generally we determine mass by charge, mass by Q for the different molecules. Then another possibility, so we have a bonding electron, whatever, because when the molecule is hit, so there is a chance of removal of core electron and also the possibility of removal of a bonding electron. So the electron between a hydrogen and carbon, when this is a bombarded, the electron beam is bombarded, there is a chance of hitting out the bonding electron. Okay, then there is formation of a neutral H plus, so there is one electron and one proton, and it will pass as it is in the mass analyzer, because in mass spectrometry the only those molecules will be detected which are ionized, okay, and other molecules will be not detected with the detector. And so now, okay, so now we will how we can, so there is a removal of core electron as well as the removal of bonding electron, and based on that one, what are the fragments that we will see in the mass spectrograph, okay, or a mass spectrum. And generally mass spectrum consists of y-axis m by z or q, and we have a y-axis relative abundance. So generally for the molecular ion, okay, we will get peak at a 44, okay, and so that is a 44 gram per mole, okay. And another chance for removal of a one when the electron beam hit with the bonding electron, so there is a removal of hydrogen neutral, okay, proton from the molecules. So we will get the peak at a 44, okay. And there is again possibility of a hitting CH3 and CH2. Then we will so this molecule is suppose formation of carbocation CH3 plus. Then we will get peak at a 15. And suppose there is a hitting of this bonding electron, and this CH3 will be a neutral molecule. So we will have molecular mass 29. Okay. So this is another possibility for getting m by z in the mass spectrum. So these are the possibility by which we will get a different fragmented peaks, okay, different fragmented peaks in a mass spectrum. Okay, so we should also know what is the difference between a spectrum and a spectra. So single, it is a spectrum. Okay, so if we will have a different spectrum, then it will be called as a spectra. So more than one spectrum is called spectra. Okay. So this is about how we can get a peaks in a mass spectrometry. Another one we will see the chemical ionization. So chemical ionization is developed after the electron ionization. So we are using high energy in a electron ionization, and there are a more number of fragmented peaks, and sometimes it is very difficult to identify the different peaks formed in the spectrum. So we will use a chemical ionization. So in chemical ionization we will use methane or ammonia as a reagent gas. Okay, so here in this technique we will not directly ionize the molecule. First we will ionize the reagent gas like methane and ammonia. After the ionization, this methane or this ionized methane or ionized ammonia will ionize the molecules, okay, for identification of a sample. So these are the different schemes. Okay, suppose first we will ionize the methane molecule. So after the different several steps, it will form a CH5 ionized methane molecule, and this ionized methane molecule hit the ionize the your molecules in order to prevent less number of fragmented peaks in a mass spectrum. And so here the ionized molecule is a M plus H, okay, instead of a M plus, okay, carbocation. So these are the different steps by which the chemical ionization can be understand. Okay. Then we have a fast atom bombardment. Okay, fast atom. So the term. So here we will use atoms. Okay, elements for a ionization of molecules. And here generally we will use a inert gas, argon or xenon. Okay, so the atom of a argon or a xenon is used to ionize the molecule, and here we will use some matrix. Okay, matrix. So this gas element is mixed with like glycerol, glycerol. Okay, so this is like, here we can understand the mechanism by which the molecules can be ionized. So here the green color. So the green color is we have a analyte. So the element which you are going to analyze, and mix with some matrix like glycerol or a thioglycerol, and the addition of this matrix is prevent the direct hitting of the fast particle beam. Okay. Then next we have a soft ionization. So there are two types of soft ionization. First one is a ESI, electro spray ionization, and another one is a MALDI, matrix assisted laser desorption ionization. In ESI, E means electric field. So here electric field, with the help of electric field, the molecules are ionized. So here we will see how the molecules will get ionized. So here we can see the solvent along with the inert gas passes through the stainless steel. Okay, stainless steel, and along with a sample, and there is a high electric field is applied to this stainless steel sprayer, and with the help of electric field, the molecules form or you can say the molecules will get ionized with the help of applying electric field. Here, because there you can see we are supplying some voltage, okay, to the molecules which we are passing through the liquid. And in MALDI, generally we will use some matrix like a 2-hydroxybenzoic acid DHB or CHA, cyanohydroxycinnamic acid, and we will mix the matrix with the molecules. Like if you want to determine some protein, so we will mix with the matrix, and matrix along with your analyte. Okay, so we will keep that the matrix along with your molecule on some sample plate, and when here we will use the laser light. Okay, laser light for a ionization of a molecules. Here we can see the green color in a light will ionize and it pass through the detector. So they are the pioneer for the development of a ESI and a MALDI mass, and for this development they have got the Nobel Prize in 2002. So in the previous slide I told about the matrix. Suppose if you want to determine peptides, nucleotides or oligonucleotides, we have to use 2,5-dihydroxybenzoic acid, and it is also called DBA, and we will use 337 to 335 nanometer wavelength of a laser light. So there are different types of molecules, or we can write this in the application portion. Okay, the application of mass spectrometry for analysis of a different biomolecules using a different matrix. Now we will see what are the different mass analyzer, and the understanding of these different mass analyzer will tell us about the resolution, sensitivity and selectivity for detection of molecules in a mass spectrometry. So we have a magnetic sector analyzer, and that is a good for high resolution and exact mass, or we can using this sector analyzer we can get the accurate result. Okay, then we have a quadrupole analyzer, and a good resolution, fast and a low cost. Okay, and time of flight. Using this mass analyzer we can determine the molecular mass, higher molecular mass. Okay, then we have a quadrupole QIT, good resolution, and finally we have a ion cyclotron resonance, that is also called FTICR, and using this one we have a highest resolution and having a accurate, but this instrument is very expensive. Okay, so these are the this slide showing the instrument with a different resolution and accuracy, because the resolution and the mass accuracy is very important component in an analytical technique. So we have GCMS, using GCMS having a triple quadrupole. Okay, triple quadrupole, and we can using this quadrupole mass analyzer we can determine the compound which having a molecular mass of a 2000, but the limitation is a low resolution. Then sector, if you are using sector mass analyzer we can determine the molecular mass up to 4000, and resolution is a 50,000 to 100,000, and the accuracy 0.005%. In terms of the ppm it will be 5 ppm, and FTICR is a more accurate technique, or giving a accuracy for analysis of a molecule in a different mass spectrometry. Then we will finally see the analyzer. So this is a sector analyzer, and the sector analyzer, this is a very old mass analyzer, where this analyzer based on, so here when the molecules get ionized in a ionizer, then it passes through the magnetic field. It passes through the magnetic field, and here the ions, only those ionized molecule will reach to the detector whose frequency is same as the frequency of a applied magnetic field. So this is a working principle of a sector mass analyzer. We have a quadrupole mass analyzer. Quadrupole means 4 metal rods are parallelly arranged. Okay, and here the separation of ions in quadrupole mass analyzer depends upon the applied voltage to the quadrupole, to the radio frequency of the ions which travels inside the quadrupole, and only those ions reaching to the detector which frequency is matching with the applied voltage of a quadrupole. So this is a principle behind the quadrupole. And finally we have a time of flight. So time of flight means the so what time the ions takes from origin to reaching to the detector. So here the time of flight based on the lighter ions. Here you can see the different colors. So the yellow color ions is a lighter molecular mass, then followed by the red one, then blue one. So here the lighter ions in the time of flight reach first, followed by the bigger molecular mass. So then that is called time of flight. Okay. Then finally we have a ion trap. So ion trap we have a what here again this ion trap again, this is a this one having a 3 electrode, ring electrode and entrance end cap electrode and exit end cap electrode. Here the ions are trapped in three-dimensional we can say ring. Okay, three-dimensional ring. And here again the ions, only those ions reaching to the detector, which means because the ions again having a particular frequency, okay, of a moving zigzag in the 3D box. Okay, we can say the trapping of ions in a 3D box, and the whose voltage, okay, voltage and the frequency of the ionized molecules matching. Okay, so that will reach to the detector in a ion trap. Finally, we have a detector. Generally, we can use photomultiplier tube or a MCP, micro channel plate, and generally photomultiplier tube. So here this PMT is made up of several diodes. So here we can see several diodes, red colored. These are the diodes, and these diodes are made up of a semiconductor material. Okay, semiconductor material. When the first we know this, first the molecules get ionized, then it's separated to the mass analyzer, then finally the ions reaching to the diodes. Okay, this we can say these ions in the form of photo electron reaching to this diode, and these diodes will multiply this photoelectron. Okay, photoelectron, and finally it take off by the anode, and we will get finally electrical signal using photomultiplier tube. Similarly, the MCP micro channel plate works same as a photomultiplier tube, but it is a parallelly arranged. Okay, so this here again it is a we can say micro channel plates are semiconductor material, but it is a parallelly arranged. Okay, for detection of ions in a mass spectrometry. So this is about a mass spectrometry. Thank you.